and then these two are equivalent. That means your 3 into 9. So there are 9 peaks over here. These 9 comes around due to this particular group, NH2. Is it clear? So what is happening? I'm repeating this thing, that here this OH that is directly connected to the carbon center. Okay, but that is not being reflected as far as the X band is concerned. So I am trying to defend myself by considering the fact possibly Q band region it would be visible or resolved, possibly. And these are all carbon center response. So forget it. Now here again 3 bond, 1, 2, 3. Here only 2 bond. The third bond even active. If it is not being active, then you should expect that 1 line into 3 lines that you are already getting. Okay, and each of the 3 lines again split it into multiple lines. Now multiple lines means if I consider only nitrogen, then I should expect only 3 lines here, 3 lines here, 3 lines here. But here, if you look at carefully, more than 3 lines, even 3 times more than 3 lines. Possibly that these 2 hydrogens are also coming into the picture. So 3 into 3, 9 lines. So each of these three signals are getting, they're splitted further into 9 lines. So this is how, and this is where the complications are. But it's understandable. Now if you move into the benzyl radical, you see I have picked up the examples where some complications are there so that you are aware of all the complications. Okay. Now let us look at this particular benzyl radical. Now here you'll be getting triplet naturally. 2 into 2 into half plus 1, so 3 lines. But you are getting 100 lines. I'm joking actually. Yeah. I also don't know how many lines are there. So many lines are there with the different intensities. I'm keeping intensity completely aside. That's why I said in the beginning, unless the molecule is very simple, do not go into the calculation of your lines. Okay, go for calculation where it is like methyl radical. You can calculate the intensity ratio. But here what to do? Even if you go into, you will be swimming into the ocean. But anyway, so that's a simulation would help you actually. Simulation through computation, you will be getting the exact value. 1:1, 1:2, 1:2, whatever it is, the exact value. Now, if you consider this is 3 lines, and then you have 5 equivalent protons over here. Right? 1, 2, 3, 4, 5. 5 means you will be getting 6 lines. So 6 into 3, 18 lines. It is manifold of 18. So certainly this consideration is not correct. So if I give you this spectrum and ask you to interpret this thing, looking at this molecule, you will be puzzled because you can maximum calculate up to 18 lines. Forget about intensity ratio. But it is much more than the simple calculated value of 18. Okay. Now, one could imagine in the following directions. Look at this resonating form. Now, if you look at this resonating form, this radical could revolve within the ring, not in a delocalized fashion, but in a localized fashion. Remember the term what I am using. Not in a delocalized fashion, but in a localized fashion. That means one time it will be ortho to this group, then para to this group, and then ortho to this group. And if the localized structure persists over here, then each structure would have its own number. For example, here you can think about 18. Here, if you see it, then this number would always be there. So, and here if you see it, that this, all 4 you have to consider. Here again, if you consider these 2 are equivalent, these 2 are equivalent. So number 2 would come into the picture. Here, like this situation. So if you put all these possibilities together, and each is having its own number, and then you club it. And if you collect all these things together, then you will be getting such a kind of nasty spectrum. electron. I'm saying nasty in terms of the difficulties in calculating the number of lines. Okay, but otherwise it's very interesting. Yeah. Okay. Now let us look at another molecule. Here you can have two type of answers. Again, it's a naphthyl radical. Now, if you consider the naphthyl radical, one could imagine, and I'm talking about in terms of anticipation. So one could imagine that this unpaired electron may be delocalized over the two rings. If it is delocalized over the two rings, then your number of protons are 1, 2, 3, 4, and 8. Then 8 means you will have 8 equivalent. If it is delocalized completely, all the protons are equivalent. If all the protons are equivalent, then you will have 8 protons. And if it is 8 protons, then 9 lines. How many lines you are getting? I have calculated around 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, whatever it is. Certainly much more than 8. That means these two are not equivalent, and it is not a delocalized situation. It's a rather a kind of localized situation. Now, if you consider this particular ring and this particular ring separately, here you have 1, 2, 3. 3 means 4 lines, right? And here you have 4 means 5. So 5 into 4, around 20. Possibly it gives the explanation of the 20 lines, around 20, 22, whatever it is. So that possibly explain that this particular electron, which is essentially localized within this ring, and that's why these 3 protons, they are equivalent and they are different with respect to these 4 protons attached to the other diffused ring. So that's why I said it tells you a lot of information about the electronic structural aspects. Okay, so electronic structural aspects means that both the rings they're fused, whether they are equivalent or not. No, electronically they are not equivalent. Not equivalent. If you inject one electron selectively, it goes to one particular ring. Okay, like the previous case. Okay, one could imagine this is the 18 lines. One could imagine, but number of lines you could get explanation only via this resonating. That means this gives you equivalent, localized radical centers, not the delocalized radical centers. So you have to keep all these things in mind. Now, if you look at this example, this is rather simple example. Why I'm saying a simple example, you see that these two are equivalent. Nah? Either you put it here or put it here, it doesn't matter. If they are equivalent, these 4 are equivalent. So 5 lines, you are getting 5 lines as per. Now here you can easily calculate the intensity ratio. That's not a big problem. But there you cannot calculate the intensity ratio. Okay, and you could see it, all the X means the carbon response. So under X band condition, in certain cases, you yourself have noticed that 1% C13 response comes so nicely, but certain set of molecules it is not appearing. So what does it mean? It means that once it appears, well and good.